We have entered Easter weekend, so some members, some attendees of this course, of this lesson, leave home. Therefore, I think that the recording could be useful for you. So make sure that we can answer this question, because I don't have time to ask this question anymore. Let me get back to these topics and explain it using the example code we have. In the example code we have, okay, so let's first close all the documents. Try to follow me, try to put the notes, because I think it is last time we discussed these terms, these topics. What is the dependency injection? How to distinguish that we have dependency injection? What is the reason we need dependency injection? What is the difference between the dependency injection and object-oriented programming? Next, my question related to this topic, because still I haven't got any real answer, or any good answer. But it's a fundamental question for you. The question is, what is the type? And next we'll try to answer the question, because next I try to answer the question, what is the collection? It is next very hard topic, I think, for you to answer in simple words, just a few words, and in the context of the program, what the collection is. Let me recall you that in all of the cases, if I am asking any questions, try to answer the question in the context of the design time. We have two stages of the program in context of the development and usage of the program as a product. So we have very important stages that are important for you. If we are designing, or if you are running. If you are designing program, we are talking about the classes, about the text. We are talking about the types, about dependency injection, MVVM, and things like that. During the runtime, it is not so important, because during the design time, the discussion about the layers doesn't make sense, because we don't need layers. Actually, for us, if the program is running, doesn't matter if the program has layers or not. It's not so important, because in running program, it is impossible, for example, to replace a layer because the program is running. During design time, it is important to have layers, because we can replace the layers by another one, and it's for us the additional value. It is very important additional value to have, for example, these layers. But in the context of the language, remember, three contexts. Actually, we can distinguish three contexts. It is algorithm, discussion about how to solve the problem. It is design time of the program, where we are implementing the algorithm. Actually, these two stages are the first design time. Sometimes we are not distinguishing designing of the algorithm as independent task, as independent job, as independent activity. So writing a program, providing a text for compilation to the compiler, together with designing of the algorithms, is more or less the same process. Therefore, we don't distinguish creation of the algorithm, designing of the algorithm as independent process. Of course, it could happen. It's possible, but it's not for programmer. Usually, programmer have an algorithm or the design patterns, and dependency injection is one of that. Okay, I think you have answered. What is the type? So let me ask, what is the complex type? What is the difference between simple and complex? I skipped the question about the simple type. Just get to the complex type, but during this lecture discussion, let me show you dependency injection. First, an introduction. Dependency injection application is just an application that's running. It's something that has user interface, so we can execute it. Right click, and here it's debug. Start an instance. After compilation, we should get user interface. It takes a while. The interface is on my second screen, but here you can see the user interface. It is console application, therefore the user interface is just a text, but it's running. It provides some information on the screen. This information is, of course, data. So to know what the data represent, what it means, we need something like a code. We know that we are using alphabet that contains all the characters from the native alphabet, but we must understand, for example, what the idea is. Of course, it's very difficult to know it. Therefore, it's easier to talk about the information. It's abstract, so we don't know what it means, but we know there is something on the screen. So we must look inside this code to have information about what it means, and especially now we are talking about the testing the application. So we expect that after the testing of the application, we'll get answer if the application works as expected and provides data as expected and provides result as expected. Here, for example, we have some names, and this screen is usually useless for assessing correctness of the application. It's impossible to say if the application is working as expected. Therefore, we are trying to do something else, and instead of testing of the application using the user interface, the user interface depends on the coding system we are using, about information that is provided, about the expectation of the program, how it works. Therefore, we're trying to do something else, something different, and we call it unit test. So the same application. Can you still see my screen? Okay, thanks. So my next question is, okay, what is collection? What's collection? Because still we don't... I try to get back to these topics during my explanation, but here you can see, that we have... I try to enlarge the screen. Just a second. In the meantime, you have time. Oh, yes. Here you can see introduction unit test, that it's unit test, and using this unit test, we try to do the same, to assess the correctness of the application, and we are expecting the result yes or no. It's correct or it's not correct. Therefore, using the unit test, here is the result, test and window test explorer. I'm using the older version of the Visual Studio. Maybe the interface is different, but still actually the functionality is more or less the same. The test window is somewhere over here. Let me oh, it's here. So I can, as you can see, here we can run the test introduction. It's here, but doesn't matter. The answer is it's in two colors, in the green and the red. So actually, this way it's easier. This way is easier to test if the behavior is okay or not okay, because we have only two colors, and we can actually use just a simple condition, yes or no, to assess if the software is correct or no. But still, it depends what we are going to test, what we are going to expect, what is expected from the software. Let's get back to the software. I'm still going to discuss what is dependency injection, but by at the same time, I'm trying to explain some additional topics that you will bother during the task one. So finally, we are going to test the library. It is just library, and in this library we have this this class, and let's focus. Let's discuss only on this class and the correctness of this class. In this class, we have constructor, we have a few methods, alpha, bravo, Charlie, delta, and that's all. Actually, that's all. The functionality of this method is very simple. The method just call trace event from the local variable. So we are expecting that this variable contains a value. As you can see, the value expected here must be compliant with the interface. Go to definition. It's just an interface, and this interface provides definition only of one method, trace data, with the parameters. So it doesn't matter what the parameters means now. The most important thing is that it is just this method. Now, first question that we have always in the context of the interface, it's what the functionality is provided by this method. We don't have method here. Let me stress it. We only have a signature of the method. We only have a header of the method. So we know the name and list of formal arguments of the method. We doesn't have any information about functionality. We don't have block of statements here. The block of statement is implemented. The block of statement is responsible to implement selected functionality. So in terms of the algorithm, we have functionality. In terms of the program, the functionality is implemented using the block, using the instruction, and finally using appropriate types. Because all the definitions, all the methods, and all the properties in this language and in most of the languages I know that support object-oriented programming are embedded into the types, into the classes or other types. So functionality, if we are talking about algorithm, and instruction and statements in context of the language, it is so instruction and statements are implementation of the algorithm, but methods provide additional metadata, provides name, provides arguments, so actually allows us to provide more flexible definition. Okay, but today I ask the question: what is the reason we need abstraction? It is abstract definition. If you are talking about the definition about the declaration, it's just declaration. We are declaring here that we have a method trace data, but without any additional information about the implementation. Therefore, we call it abstract definition. Abstract definition means that we are hiding, we are not providing details about the implementation. Why we need abstract definition? Why we need abstraction? Why? What is the reason we are using? What is the reason we are using abstraction in general? The answer is that we need polymorphism. Polymorphism is required. It is if the problem is polymorphic, we need to use abstraction to solve the problem in a common way. Common means that we have the common definition, but different implementation. It means that we have actually two independent implementation of the same abstraction. I hope you are following me, because now it is time to ask, okay, if we need abstraction, it means that we have polymorphism. How to prove it? Find all implementation. Go to implementation. As you can see, we have two implementation. It is one implementation and it is second implementation. It is embedded in another classes. Here, one implementation is provided by the class in the unit test. The second implementation is provided here. It is, we can check it. It's also in unit test, but in a different place. So here we have two implementation, but I expect that we have also additional implementation for the program. It's phrasing. It is provided. No, it is just definition of this. Oh, yes, this class This class provides implementation, and this implementation is located in the application. So actually, in this case, we have 3 independent implementation. 2 implementation is dedicated for the unit test, and 1 implementation is dedicated for the dependency injection application, for the application. Why? We need different implementations. Because we are expecting different behavior of the testing procedure depending on the place where the test is located. If the test is located in the console application, in this case dependency injection application, here we need to display appropriate text on the screen. So let me recall the screen. The screen is like, I hope it will be faster now. Yes. Can you see that here we are getting the text on the screen? It is exactly execution of this implementation of the trace data method. We are by this way we are calling it tracing. We are tracing behavior of the program, so we can observe the sequence of the execution, sequence of operation we are executing. Here's on the screen. From this implementation, you can learn what means this identifier here. ID, it is ID. It's just a identifier, and what means this part here for them entering. We are writing here entering alpha. Of course, it depends on the actual parameter, because here we have only formal arguments. Therefore, it depends where we are calling. So let's go find all references. Here you can see that we are calling this method in all of these methods, and the text we are providing, it's here, entering data. You can find it on the right side, entering Bravo, Charlie, and Delta. It is exactly what we have here. But the definition here is not provided. Still, we are using the variable, is variable, but the type is abstract. If the type is abstract, the question is about the implementation. But here we doesn't care about the functionality. The functionality must depend on the place where we are trying, where we need this functionality. If we need this functionality in the execution part of the program, in the console application, the functionality means that we provides a text on the screen. But in case of tests, I'm getting back to the test, and here is it. In the test, we also trace the data, and we are tracing the data here. It is just a memory. It is just in memory value holder, just a list. that we provide appropriate information. So here is the implementation of this method. We are adding just the text, appropriate text to this list. After that, we can check the consistency. Consistency means that the program behaves as expected. So the behavior it's correct. Actually, it means correct. So we can check, for example, that first on the list we can have identifier alpha. Second, Bravo, Charlie, and Delta. So the same we can find on the screen here, Alpha, Bravo, Charlie, Delta. So we know now that the name is the name of the method. It is the name of it. We try to provide the name of the method, but here is one implementation, and previously constructor injection here. Console trace, let me once more prove that is located inside of the project that has user interface. We have second implementation. These two implementation we are using for testing using the graphical user interface and for testing using only the unit test. In graphical user interface, we need to check correctness manually. So we must assess this on the screen and say, okay, everything is okay. Therefore, the application, we can grade this application as okay, so as passed, as that everything is as expected. But the same functionality is provided by in-memory test by the check consistency. Here we are doing exactly the same. We are calling a method, and the method checks if the behavior of the application is as expected. Okay. Hope that everything it's clear for you. You have disappeared from my screen, therefore I try to find the window with your communication. I can't see any hand raised. Therefore, let me ask next question that also have been not answered. What is the liar? Of course, the question is the context of programming, context of programming. Okay, but let's go back to the program and let's go back to the definition. So finally, we can learn two independent methods we can apply to check behavior or correctness of the data returned from a functionality provided by a library. So let's get back to the library. Here is the library. The library, it's constructor injection. It's also from the injection, we can guess that here we are talking about the injection. So the question is, what is injection? First, dependency it's one question, and second question is, what is injection? Trying to answer the question, trying to explain the pattern dependency injection, it is, I think, very important question. So let me first provide wrong answers. Make sure that this is wrong answer. It is not correct answer. I'm asking what the dependency injection is, and usually you provide me answers like this. Here there is a formal parameter, and this formal parameter is abstract type, is of abstract type. And in this constructor, it is just a method that we call during creation of an object of this class. We are assigning, if it's not empty, if it's not null, we are assigning to this variable. Therefore, we have an object that actually depends on the object, the reference we have here. So let's try to explain all the errors. First error is that here we are talking about the object. Here we are talking about the class. We are talking about the design time. So it is class. It is not object. The object will be after creation. Here is the constructor. And this constructor has formal parameter, formal argument. It is something extra. It is something that it is not covered. It is not addressed by the language. Of course, no. In all of the languages, we have methods. In all of the languages we know, we have parameters, formal parameters, or formal arguments. Depending on the language, we are using different terms. But in all of the cases, we have here it is just a formal parameter. It is value holder. If it's value holder, it is just a variable. Therefore, here we have variable. Here we have another variable. In this case, this variable we call field. In this language, we call field, but in other languages, we just call it variable. It is next. It is value holder. This value holder disappears after finishing of this method. So after finishing it in this place, it disappears. But this value holder disappears after. Now we are talking about the runtime. In the design time, this variable and this variable is the same. It is just variable. We are not talking about the life life cycles of the variables in the design time. But in the runtime, yes. In the runtime, we know that this variable disappears after returning from this method, and this variable disappears after destroying the object of this class. Object. To call this method, we need an object, or actually the new statement that creates new object. In any case, we are creating an object, and after that we are calling a method or constructor against this object. So it is nothing extra. It is nothing special. It is just a variable, and it is just a type. Doesn't matter what type it is, but in all of the cases, always. In all of the cases, always it is just a type. Doesn't matter if it's abstract or no. If it's abstract and if it's a reference type, we can talk about object-oriented programming. It's possible to talk about object-oriented programming. So here it is an example where we have object-oriented programming, because we know that here there is during the runtime an object, and here we have a reference to this object assigned from this formal parameter. But still, we are talking only about object-oriented programming. It has nothing in common with dependency injection. Things like that we have in all of the places a lot. Therefore, we must take care about it. So if we don't have dependency injection here, and actually, do we have any injection here? What is the injection? Of course, the only operation that we have in the language that it recalls injection, the same behavior, so we can put something inside another thing. It is just assignment here inside this class as is a variable, and we are assigning to this variable new value. Therefore, we are putting something inside another thing. Of course, during the runtime it is the text, but during the design time it's just the text. But during the runtime, it is value holder. Therefore, here we are injecting something. So, for example, we can call it injection inside of the assignment. But in terms of the language, it is assignment. Therefore, there is no need to provide additional term, to provide additional word that we are used to describe the same functionality, the same statement, because in this case, it is just a statement, it's assignment statement. So so the next error here is that the mistake here is it's calling it injection, because we don't inject it. We're just assigning it to the variable. So maybe the answer is where we call this constructor injection. Let's find, go to definition, find all references. Because we have polymorphism, I expect at least 2 implementation. And the implementation to make useful an implementation, to make useful in the definition of the class, we must create an object. So I expect at least 2 instruction, at least 2 statement where we are, 2 expression where we are creating an object from this class. One is the constructor injection here. It is in the main program. You can see that here we can find the main program. So after running the program, so after executing the program, it is the first statement executed by the program. And here we are just creating an object using new operator. There is another possibility to create an object. We learned about it later today. Hopefully, we'll have time to do it. But it is something that we can call dependency injection. It is just a class. And it is just a new. And right side, it is just an expression. It's just an expression. Usually, expression from the new. It is expression. It's the parameter of the new. The parameter of the new must be F12, must be constructor of the class. It is required by any languages. Doesn't matter if it's Java or C# or any others, object-oriented programming. But here we are just creating an object. There's something special. Is something we can call dependency injection? Of course, no. Of course, no. It's a typical operation that that we have a bunch of similar statement like that. you can see that next in this main program we are calling all the methods, and finally we will get on the screen. We'll get on the screen appropriate text that can be used to assess if the sequence is correct. So the functionality here is very, very primitive. So don't expect from this any. It's not very clever. So it must happen that all the methods we are calling in the good sequence. The last statement is only to keep the screen, to keep the window on the screen, to keep the user interface on the screen. Because after finishing the program, after executing a last statement in the program, the user interface disappears because the operating system cancels, remove the process from the memory. So to finish the process and remove the process from the memory, therefore it must also remove the user interface from the screen. Let's get back to the dependency injection. Maybe the next suspect, it is the parameter here, because here we are providing reference to an object. It's next object. It's next, it's next class. What is the difference between this and between this? It's the same new operation. Therefore, we cannot call it here dependency injection. We are just assigning reference to a new object, console trace. Big definition, let me recall that the class is responsible to provide one big definition. Why it doesn't work? Oh, maybe big definition now. Yes, I selected also the new, and it doesn't work. So you remember, and let me recall that it is just implementation of this right line, of this trace data method, because it implements it is one of the implementation of this abstraction. It is one polymorphic implementation, one polymorphic approach, where we are using user interface and provide text on the user interface. Therefore, here we don't have dependency injection, and here we also doesn't have dependency injection. So still the question is where the dependency injection is. To answer this question, we need to go to the next question. Do you remember what condition decides? Let me ask it once more, but without letting you provide the answer. In just a second, still you have disappeared my screens. I have two screens, but too many windows to manage altogether on these two screens. Therefore, sometimes I need a time to find the appropriate window to see if there is an activity from your side. So I'm not expecting the answer to this question, but the question is, what condition decides about necessity to use dependency injection? Maybe in this question we can find appropriate answer. What is dependency injection? Let's try here to replace this. The program is still running, so it's impossible to modify it. I finished the program, but now let's try to do it. Sorry. Instead of using parameters, let's do this. because we have here, we have assigned a reference to a new object from the console trace source. So instead of using this parameter now becomes useless, but let's try to do it this way. Why we need the trace, this argument, this parameter? Of course, the case is that this way we don't deal with the polymorphism because we have selected appropriate implementation. But always it is possible, for example, here to deal with the polymorphism using, for example, switch or if instruction, and create appropriate object. So forgot about the polymorphism. Let's try to answer the question why it is impossible to create. Why it's impossible to create the object of this type. Let's go to definition. Of course, it doesn't work. Why? The answer is very simple. Because we don't have access. Here we are over here. We are in the library. We are inside of the library. And we can use only the types that we have on the references. So the references list provides information to the compiler where we can, what we can use, what types we can use. But because the type console trace, it's where is the console trace? Just a second. Trace source. It is console trace here. So the name of the file, as you can see, the name of the file and the name of the class is not the same. Therefore, it is very important to distinguish what is the file and what is the text, what is the definition. But still, this type is defined in the project that we cannot access. It's impossible to get access to this project from introduction because on the references list, we don't have dependencies injection application. Okay, if not, let's do it. Let's add it. Add a reference. So let's say the compiler that we are going to use projects. On the projects, it's dependency application here. Put the mark here and say OK. It is something strange because it's impossible to add the reference because could not be added. Adding this project is a reference, as a reference would cause a circular dependencies. What it means, circular dependencies? It means that the introduction depends on the dependency injection application. And the dependency injection application depends on the introduction because the introduction is on the list in the references. Why it is impossible? It is impossible because the application is layered. The application is layered, therefore the layer above could access only the layer below. It's only, but it's just theory. It's just a pattern. But in this case, the result is it's very simple. You can answer this question analyzing the option we have build dependencies, build order, project, build order. You can see that here There's a lot of projects, and the build order must be well defined. So using the dependency injection application, actually compiling the dependency application, we need compile introduction. So first it's dependency injection application, second it's introduction on the list, but we are compiling from the top to bottom. First is introduction, second is dependency application. After providing the opposite reference, so from introduction to dependency injection, so the question is, which one project must be compiled first? If the dependency injection depends on the introduction, and introduction depends on the dependency injection application, it is impossible to solve this problem because we have circular references, we have circular dependencies, as we can learn from the message. Therefore, we cannot get access to this class from the introduction because the class is implemented in the dependency injection application. Okay, if it's impossible, so the answer is that here object-oriented programming is not enough. We need to provide something extra because we cannot use the new operator to create new object because we don't know the class. It is the answer of the question. What is the reason we are using? What is the reason we are using dependency injection? We are using dependency injection in all of the cases that creation of the object is impossible. In this case, it is impossible. We cannot provide references. Without references, we don't know the type. Without knowing the type, we can use new operator. Therefore, this approach, it is impossible. Therefore, we need to create the object outside. For us, it's not important. For us, it's not important that here we need dependency on the other object. It doesn't matter. We can create this object inside. It's okay. But the most important thing is that it's impossible to create the object we must depend on, but we must depend on because we have polymorphism. In case of the polymorphism, we need two different definitions. If we have two different definitions, we have two places where we create appropriate, we are deciding about the functionality. Therefore, what is the answer? What is dependency injection? Dependency injection, the answer is if you try to organize this software like the code like this. So dependency injection is its necessity to provide an object to other, not object. Here it's definition of the object. So we are thinking about the runtime, but we are dealing with the design time. So during the design time, it is necessity to create, to provide instruction to statement creating new object in other place, in different place where we are using this object. It is exactly this example. We cannot create this object inside this class because we don't know the type. So we need to use this type here outside of the class that is going to use the class functionality. It is definition of the dependency injection. Of course, usually we are using framework and we are avoiding manual creation of the object like this using the new operator. And recently I've I've noticed I've noticed a course. I am noticed a lecture lesson that the reason for dependency injection was to avoid new operator. I don't know. I don't understand why using new operator. It's so strange. It's so we should avoid it. No, it's not. It's not the problem. The problem is to avoid access to the type that we don't know the type, because, and finally, is the answer, because the type is created later in time. Let's get back to the definition. Let's get back to the definition of the compilation sequence. Project build order. First we are building this introduction. Building introduction, the type we are going to use doesn't exist. It will exist after compiling dependency injection application or functional programming unit test. I'm not sure if this introduction unit test, where is the introduction unit here? So actually the type is created for the compiler. It's created later. First, this type is compiled. Next, this type is compiled. Next, doesn't matter that there's only a few milliseconds or microseconds. It's later. In all of the cases, it's later. So dependency injection is to refer to the types using object of the types that we don't know, because the type is created later. Doesn't matter if it's created 1 milliseconds later, or it's created a couple of years later. Doesn't matter. In all of the cases, it works the same. The only what we can do is to replace new by something else that could help us to create appropriate object in appropriate places. But the idea is over here. Why you need to use dependency injection? Because you are using unit test, and you must refer in unit test to the introduction. So some types that is created for testing must be created in the unit test. It must be created there. If it's created in the unit test, it's impossible to get access to this type in the type that is created that is created first. Is dependency injection. Okay, do we have more time? What is the... Oh, we have a couple of minutes, so let's get back to the next topic. Next topic is collection. I discussed it in many times, but what is the collection? What does the collection go to in-memory unit test? For example, here we have a type. We are referring to type that we call list. The definition is provided by the F12. Help us to find the definition, and the definition is provided by Microsoft, by the basic library. So it is type embedded in the language environment. It supports compiler, it supports Visual Studio, it supports design. So it's part of design environment. But here why we are using here collection? Because it's collection. Main reason for collection is that that it's organization of the data. It is a set, but the set has some additional features. We'll learn this feature later. But for us, the most important here thing is that we can add a new item to this container at any time, and we don't need to think about how many items we can add to the container. Let me recall, the array is also a container, but usually the arrays, in most of the languages, the arrays is static. So we must provide number of items in advance, where we are defining an array. So adding one element, so number of elements in array doesn't match number of elements actually added to this array. For example, if we have the length of the array, it's 4 entities, and assigning only the index number, for example 0, we have only one element inside of the memory. But for us, it's very difficult to find how many elements in the memory we have, because in all of the cases the memory contains 4 elements. In the containers like collection, it differs, but it's everything what I said. It's in terms of the algorithm, in terms of the theory. It's terms of its answer in terms of the expected behavior of the program. But we must answer the question in terms of the language. So what is the collection in terms of the language? Of course, the answer we must find analyzing the definition, analyzing the details of the definition. F12 allows us to go to the definition, and here you can see. I'm pretty sure that I discussed it, and I've described it previously, but still I'm getting no answers or wrong answers related to the collection. But the first task is related to collection. So without appropriate knowledge, without knowing what the collection is, it's impossible to pass the task one. Therefore, let me get back to this topic and waste the time in case you know what the collection is. But the answer you can find simply here. We have abstraction, collection. As previously, we are referring to the object-oriented programming. And as previously, we talk about abstraction. So we need, using the abstraction, we need a polymorphism. In this case, polymorphism means that we have many implementation of this interface. After pressing F1, you can get help information, and you can see here a list of types that derives from this interface. How many types we have that derives from this interface? So definitely we can say that we have polymorphism. Polymorphism means that we need a container, but the behavior of the container could be polymorphic. It could be a list, it could be a dictionary, it could be a sorted list, and things like that. So we can add additional functionality, but the basic functionality must be provided as a collection. Here we are using only a list, and we can see that I collection is on the list. Therefore, we can say, in terms of the language, that the list is a collection. So answering the question what the collection is, the correct answer is any type that derives, that inherits I collection, that implements I collection. It means that we are inheriting, because it is just, go to definition, it is just interface. We must implement this interface, because the interface, from the definition, it is abstract construct. It is abstract construct. Therefore, we must implement it, and from this we can guess that list as a concrete type, it implements also I collection. If it implements I collection, we can assign that the list provides appropriate functionality expected from the definition of this abstraction. So this abstraction provides basic definition. It's a list of signature that we must implement. Of course, this way we are not defining how, for example, add operation works. It could depend on the concrete implementation. It could differ from sorted list. It could differ for dictionary or the list. So we can insert an item, insert an entity between selected two entities that we have in this container, in the object during execution time. But still, this way we don't select which one we need to use to insert something between. But we have add operation. Because there is no additional restriction related to the add operation, we can assume that add operation can be executed at any time. So it's not limited. It's not limited. The number of items in the collection is not limited. At any time, we can add additional one. We can also have clear and next operation. But additionally, what is important here, we can learn how many items we have in the collection. But very interesting question is, if the collection is sorted, or if the collection it's if it's just a set, or it's just a sequence of elements. From this inheritance, from this definition of the interfaces, go to definition, we can learn that, go to definition, that we are returning from that this implementation of this must provide implementation of the method getEnumerator. And getEnumerator provide appropriate IEnumerator type. Using this IEnumerator, big definition to make things easier, we can learn that we can distinguish current elements. So one element is a special one, because we can get access directly to it using the current element. We can move next. If we can move next, we can assume that all elements create a sequence, because for each element we can define next. We can define next one. Okay, I think that's all about the collection. So let's get to the next topics. Today we need to discuss reflection. So let's go now for the. I hope that everything is clear now for everything is clear for the task one, how to accomplish task one. Everything now you know. If there is still any problems and misunderstandings, and you are not sure about my expectation, just contact me, so we'll organize consultancy, special consultancy. We can discuss also some selected topics during the project today. So the next lesson I have is a project, and during this lesson we try to get back to some questions and try to of course the schedule is more complicated because we must create all the repositories, and we can clone. I must clone all the repositories to make sure that next time we will have environment to discuss about the task one. So what is reflection for you? I'm asking this question, and on the chat. Sorry, but the chat doesn't work for some reasons. I don't know why. As usual, something must be wrong. Oh, now it works. Okay. Hope now it does. What is reflection for you? Try to answer this question to get some points of activity. Let me recall that you can also get activities point contributing to the repository containing examples of the code. So there's no need to get all the points this way. It's also possible, as I said, to develop new functionality in the repository we have actually. But now let me go to appropriate methods. You have time to answer the question. I close all documents. No. I need attached property. I need attached property. Actually, attached property we have over here, and we have also in the unit test. So still there is someone that tried to answer the question, what is the reflection? Next question, mine. Previously, discussing dependency injection, let me recall that injection, it means that we are assigning, actually it is assigning to the parameter. It could be also assigning to the property. But assigning of the reference to a type we can create inside. It is minor reason, but it is, I mentioned about another possibilities. How to create. What's wrong with? Oh, now it works. Now my question is how to inject in the dependency without using an assignment instruction, assignment statement. But to discuss what the, and answering to the question what the reflection is, you can, the first answer you can find here. It's using this type. Let's go to the definition. You can see that also the type is provided by the system namespace. It's provided by the mascot lib, so it is base functionality of the development environment. But we are telling, we are defining reflection like possibility to use type inside of the type, inside of the program. Usually we are using a type. For example, here, attached property, you can see this is just a type. It is class. Additionally, this class is a generic class, so here we have type parameter. We have a parameter that we must assign during creation of this, of the object of this type. We must assign to provide definition of the concrete type. But here we are using this type as a type of a variable. It is value holder, and this value holder we are assigning, actually we are assigning a value, but the value, as you can learn from the name of this method, it's basic functionality provided for all of the values, because all of the values derives from the object, from this class. Even if it's not reference value, if it's not reference value, it also derives from the object. Therefore, we can get type in all of the cases. But it's not type directly the type. It is object that represents, that contains all the information about the type. Therefore, we are assigning to this variable. This variable is of type, is type of type. But go me to this. Go to definition. Sorry, and go to. Okay. It is, there's something wrong, sorry. Type and go to definition. But it's abstract class. Additionally, it is not only abstract class, but it is the class. The constructor of the class is protected. Therefore, it is impossible to create. It is impossible to create object of this type. We must guess the object from the environment in all of the cases. In all of the cases, we must get this the object of this type from the environment. And here it is one example attached property. Here we are using get type of this object, data type. Another possibility to get object of the type is using special word name of. Name of also provides object, creates object of the type Here, for example, we are assigning to this variable from the parameter. It is just an object, so it could be any reference type. But if there is something wrong, if the value is null, we are throwing an exception, and in the name of the exception, we are providing the name of the type. Here, actually, it means that we are providing the name of the type. We are using toString, converting an object to the string. But what is the reason to use? So in any times it is to dealing. So getting back to the definition of the reflection. Reflection is the possibility to process the program, to treat the program, to deal with the program as a data. So in this case, we can, for example, during the running time, we can recognize types as the metadata, because usually we don't need the type during the execution type. The type is required only, the definition of the type is required only during the design time. But during the runtime, we are using the object representing the type, for example, to provide additional functionality related depending on the type. If something depends of something, this way we are referring to the value, we are referring to a value. Therefore, in this case, type is a value, type is a data. So we are processing, and here you can have an example. You can have an example. This example you can analyze, because we don't have time now to analyze it in details, but the main idea of this example is to provide possibility to assign value without assigning, without using assign statement. The value holder here is a data source, is this variable. But then, as you can see, we can assign using this property. Using this property, we can assign appropriate value without using the assignment. Here it's a get value, and here is set value. Both comes from property info, but property info is created by the reflection. Actually, it is reflection information. It provides information about the type. So here we are providing the name of the property we have in the type, and we are expecting that the property is present. And after that, we are getting information how to get access to this property for selected object. So we are processing objects. We are accessing the data in the object without assign statement. So the answer is, what is reflection? Reflection is possibility to process the text of the program as a data. It's first question. Second is how to inject using a reflection. Using reflection, we can, of course, not all the examples are here, because it's there is books related to this topic. For it's impossible just to a couple of minutes explain everything about the reflection, but in our case, we need three examples, three places where the reflection is used. First, the reflection you are using in dependency injection to create an object and to assign an object. Second, we are using reflection using the XAML in the second task. So we'll get back to this topic in second task, where there are examples of the reflection. So it's everything for today. I think the time is over. So let me